Good afternoon, everyone, and welcome back to Tinker Tom. Today, we are discussing NotebookLM again, but we're going to move beyond the user interface and explore the mechanics of the tool. So, to the average user, uploading a document and getting an instant, well-thought-out summary feels like magic. But underneath the hood of the car, this experience is actually the result of carefully engineered data architecture. So today what we're going to do is we're going to deconstruct that workflow, what's happening underneath the hood, to understand how NotebookLM grounds its reasoning, which is the act of tethering AI to specific facts, aka the sources we provide it, and how that is mechanically enforced within the system and within NotebookLM. So we'll be using mostly PowerPoint today to help visualize what's happening on the back end. We will switch over to the user interface view a few times just to understand what's happening on the user side of things. But we'll be focusing on a few primary mechanisms of the technology and the system's architectures, which are the bounding systems, chunking, embedding, retrieval augmentation, and transformers. And we'll look at those processes and what's happening behind the scenes to make all of this happen. So before we get into the code and have a look at it, we also need to understand the philosophy behind the AI and what we typically think of from chatbots that we are interacting with, which mostly draws its information from the open internet. And that can be crazy. It can be unverified information. Obviously, the web has a lot of information, so there's some hallucinating and maybe some less verified information being given as an output. The difference between, let's say, a ChatGPT and a NotebookLM is that NotebookLM is built as a source-grounded AI. Essentially, NotebookLM prioritizes the documents and sources you upload. And so that architecture allows for a narrower intelligence, because it's given the specific body of sources and documents, so it can avoid hallucinating and generating answers from millions of data on the internet. So the goal of NotebookLM then isn't to be a tool that knows everything, which ChatGPT can sometimes give that feeling, but to create a bounded cognitive amplifier, it calls it, which is a reliable environment for deep work, where the AI prioritizes uploaded PDFs, Google Docs, slides, whatever information you serve up to it. And so if we go to the user interface and sort of look at that left column on the left side, those are all the sources and sort of the bounding box of the NotebookLM's intelligence. So the sources provided can be few or many, but it becomes the foundation for the model and for reference and meaning. So the question is, what does NotebookLM exactly do with those sources to give it this superpower? So the technical journey of NotebookLM begins with ingestion. When you upload a source, the system's extraction layer strips away visual formatting and breaks the raw text into smaller, manageable fragments called chunks. These chunks are fundamental units of the system's memory, and by breaking down documents and sources into fragments, NotebookLM can then later pinpoint exactly where the paragraph or the information is in regards to what question you're asking or what synthesis it needs to do. So, how does the computer understand the meaning of those chunks? And so what it uses is called an embedding layer. And every chunk essentially is converted into a vector. And a vector is essentially a long list of numbers that captures semantic meaning. Okay, here's another big one. Semantic meaning is essentially the context and intent of the meaning behind the data in human language. So rather than processing merely keywords or syntaxes, it seeks to answer the why of why a word was used, and then relates it to specific content. So for example, on the screen, the word royalty, for example, would be numerically closer to queen and king than it would be to engine, car, or speed. So the shift from keyword matching to mathematical proximity is what allows the semantic search. So this system can find chunks that are relevant to your query, even if they don't share a keyword, for example. So this is just a visualization of what that semantic meaning looks like rather than keyword matching. So in this example, the question is, why did the project fail? And most keyword searches are going to look for information that revolves around the project plan. Whereas when you chunk and vector the information, The AI system is looking at the meaning behind the text. And so the chunk with budget constraint caused delays. The AI model is able to reason through that and help come up with an answer that's more grounded in the sources you're providing. All right, so the core architecture of, of NotebookLM is RAG. And what that is retrieval augmented generation. And RAG is essentially a framework that improves the large language model, the LLM's accuracy and relevance by fetching data from external trusted sources, such as the document databases, intranets, or web searches, before generating a response. So it bridges the gap between static training data and real-time information by reducing hallucinations and retrieving information and answers from the document context. So when you ask NotebookLM a question, the system converts that questions into numbers, finds the matching numbers in your documents, which is called a vector lookup, and it retrieves the corresponding text and then generates the answer. So it essentially acts as a constraint mechanism. And so instead of AI guessing from its general memory, which leads to hallucinations, it's forced to look it up first. And so the quality of your sources and pointing it to the right information will improve the quality of the outputs. So therefore, NotebookLM is strictly instructed to generate answers based only on the materials, which is why it's a lot different from these general chatbots. It has a very narrow search window to provide context. And so again, looking at the constraint mechanism, if you're opening up your sources to the web, there's all this general knowledge, all this random information that it's trying to pull into your answer. Whereas if you've created a funnel of the information you want it to retrieve from, you get a much more nuanced and contextually based answer. So it's not guessing, it's not hallucinating. So the brain that facilitates the synthesis is a transformer, and it's a transformer-based model based from the Gemini family. And so at its core, a transformer model is a prediction-based engine. It uses attention mechanisms to weigh the relationships between words and the retrieved chunks. And then mathematically, it calculates the probability of the next word given the grounded context of the sources we provide. And because it's grounded, it isn't just predicting language, it's synthesizing the material you've provided. And so to visualize this, think of two separate systems. You have a library and an architect. The retrieval step is the library. There's a bunch of rows of shelves containing a lot of data and information. The LLM, in this case, the Gemini large language model, is the architect. It doesn't need to know the facts beforehand. Its job is to take the building blocks provided by the sources and then synthesize them into a coherent structure. It acts as a reasoning engine, not a knowledge base in that sense. So a final piece of NotebookLM's capabilities is the model's ability to reformat data into different visuals and into different formats. So for example, it can transform your data into mind maps, frequently asked questions, reports, audio overviews, for example, which you can find on the right side of that user interface. So these tools are readily available because they're essentially structured prompts within the RAG pipeline. So it's a mediator, essentially, in a prompt telling NotebookLM what you want to do with the data. So for example, the podcast tool, it isn't a separate AI within the system. It's in the same pipeline. And all it is it's outputting a conversational script. So instead of a summary. And so the prompt then just looks different internally, but it's essentially telling NotebookLM what you want to do with the data. The system will extract themes. It'll simulate turn taking between two hosts, and then it uses text-to-speech models to render the final audio. And all of that exists within the prompting in NotebookLM. So this is just an overview of that process. So you start with raw data or sources. It gets chunked during extraction. It's then embedded and infused into the RAG engine, which then is sort of separated into that library and to the architect. And then the reasoning gives you an output based on your source context. So in conclusion, NotebookLM is really a specialist. So by transforming a massive LLM into a personal research assistant, it sort of becomes a powerhouse for semantic retrieval. So much more narrower synthesis and reformatting that doesn't hallucinate and only works on the body of sources that you provide. I hope you enjoyed this quick rundown of the technology involved, specifically for NotebookLM. Stay tuned for more videos. We're going to be detailing some of its use cases and functions in the coming weeks. Take care and have a great Sunday, and we'll see you next time.